All right, class, this is going to be um, future helicopter, and it's going to use a couple gear relations to get the thrust vectors, which are going to be the hoods that go back and forth revolute on uh, the outflow of the bottom of the helicopter to direct to create updraft as well as forward momentum. So pretty much all of it is revolute except for the two top exhaust um, manifolds on the top there. Um, Make sure you don't put the blade too far in. I think I made that mistake one time. Got that too far in there. Okay, so you got these blades here are kind of similar to the Harrier jet and the VSTOL jet that is in the military. The Harrier can actually take off like a helicopter and turn into a airplane. Um, many failed attempts to get this thing to work throughout history, and then finally the Harrier jet was the successful final flying machine. All right, so we're going to fix that in position so that these things will turn. So those are thrust vectors. So it directs the airflow down and back, or straight back if it's achieved the altitude you can take off. So when you hook these up with a gear relation, make sure they're pointing in the same direction so that you get good synchronization out of it. All right, so make sure you get the right edge so that they are actually seated properly, and get the back fan blade as well. So you can see how the curvature will direct the airflow down and back, and this is the actual way that a Harrier jet or VSTOL jet in the military actually works. So these the windows came kind of as an assembled kit. So the back, not window, but the back light cover actually is all connected to the front. So when you install that, it'll install the entire thing. Okay, so revolute the back blade, and then of course we're going to hook this all up with a gear relation. I think I missed my first attempt on this. I missed it. So did I or did I not? I'm not sure. Yeah, I think I did. Yeah, I have to repeat this. So yeah, make sure you get it in there correctly. And I think what I did on the second one is I just look at the face of that bottom of that blade and put that on the surface. There we go. All right. So these are the exhaust manifolds, and this is kind of tricky because you really have to match them up with the crease So you can see I get in there. There's no real way to get the center because the way that curvature doesn't let me get a center. So I find that middle point on that vertical line there. Make sure you get the z-axis that points, which is the blue axis, points toward. I can't really get that very well, so I want to go for the middle. So then you just make sure you select the same spot on your exhaust manifold, and there it is. And do the same with the other one. Make sure you got it in there. Alright, same thing. Make sure you line up the exact same spot. Okay. So the hardest part is getting the wheels on there. The front wheels, they really didn't put a place that you could do the slider mate and put them on there, and the back wheels are kind of probably could go back and create your own axle connector. So these I kind of tried two different ways to put this on here, and I wasn't really happy with the way I was getting the z-axis. I wanted to run along that thing so it would slide down, and I could not do that because of the way this thing was designed. The bottom window cover kind of threw off everything, and I couldn't really get the ability to slide off the front. So anyway, I'm going to come back to that one. This one also the same problem. I couldn't get it to go sideways because of the curvature, so I kind of struggle with that one as well. But ended up fastening those on there and tried a few things, and it didn't. I think I just gave up and said, "Hey, let's just fasten it on there." It's hard to get the slider to work or the parallel connector to work with it being see how that works like that. It's not the end result that you want. So you could probably do the tangent. I didn't try the tangent. Seeing how the tangent likes to have one straight edge and then one curved edge, and since they're both curved edges, I think that's why I decided not to go for the tangent. Yeah. So just go fasten them on there. I think that's the best. That's the best thing. And anyway, and do the same thing on the other side. And so definitely, other than the few games I get the Connect 4, I just posted that, and the chess game that I posted. Other than that, I think we've kept true to the engineering concept. We did jet engines, four-cylinder engine, a lot of gearboxes and all kinds of gear trains, and so we've kept pretty true to the engineering, and we're kind of returning back to the engineering a little bit with this futuristic chopper, and in reality, this chopper is pretty close to the design of the Harrier jet with the vector control. The silver things we attach there that they can rotate. So, but yeah, I mean it's definitely a plausible chopper. It's not so radical that it's not going to work. It actually does work. So I think that one you really have to. I think I fastened that on there. So you have to click on the fasten and get it to line up, because I think the way I gave it to you, it's a little not in the same alignment, and so you have to really use something to force the alignment. Make sure you get the edge. My head's in the way there. Get the edge, and there it goes. Okay. So if you use the what I use the slider make. Let's see. Yeah, slider. So the slider's not going to work because all three of those things are hooked together, and it just doesn't look right when you slide it through the chopper. And I can't get it to slide off the front of the chopper, and that was the problem. I attempted to go into the Part Studio and create a plane underneath there, and it didn't work out too good. If I had more time, I could probably do it, but so not. What I'm saying is I could put like a flat underbelly under there, and then I would have that surface that I could use as a planer. But it still is okay. The learning part of this project would be demonstrating force vector, so you can change it to create the upward and then the forward momentum of this chopper. And then the fact that this thing can the pilot can actually make those vents turn. It creates a kind of a smooth transition from upward force to upward and forward force at the same time. So it's simultaneous force pushing up on the chopper, and then eventually gets to the altitude it needs to convert into a full 100% airplane. So don't hit that center. You're going to have to go a little bit lower, because if you hit that center, what's going to happen is your axles are going to be a little bit too high, and then your wheels are going to be touching the top of the chassis there, and you don't want that. So yeah, don't pick the center right below where I just selected it, and you'll see on my second go around I'm going to actually undo this. But you can see the wheels are kind of like bowed up on the axle, and that I don't see the advantage of having the wheels like that, but that's the way they want to design it. So yeah, this is supposed to be an actual prototype that has been tested, and I forgot the company that actually had this file. I don't know if it's Raytheon or forgot. Let's go back and check. All right, so yeah, you can see that wheels are need to come further down. So I was trying to offset it going in the vertical axes, and it just wouldn't do it. So I tried though. All right, so yeah, delete that. Not sure what I'm trying to do there. Or I forgot what I was doing. Yeah, just start over, and what you want to do is yeah, revolute to make sure that the tires can turn, and then hit the, you'll see it's a little bit lower, there it is right there. So get that, and then you're going to offset it, I think it was 1.4 inches. Yeah, offset 1.4 inches on the z-axis. Okay, so yeah, 1.4 inches. So there you go, a little bit better. And front wheels are a little bit more trickier because there's no real clear way to attach those. You just kind of have to eyeball it. And so you have to line it up front and side, and then manually bring them into the chopper. You can see you're going to have to do a little bit of turning, a little bit of twisting on these things because they're not lined up. So you look at the bottom and then look how much you want to twist these things. And yeah, the wheels are not meant to let the chopper roll forward. They're just mainly meant for touchdown. And I think the reason they have them going in these weird angles is because these type of V-stall Harrier jets don't make a perfect flat landing. You know, you might tilt a little bit left or right, and so they kind of have these wheels tilted outwards to under the assumption that these things don't come down 100% straight sometimes. And I've actually seen these things when I was on the Carl-Vinson. I actually saw some of these things attempt landing. Most of them are pretty straightforward, straight down, but any wind comes along, it's hard for them to adjust quickly. So you'll see them kind of tilt to the side a lot of times. So yeah, I just kind of picked a spot to put it, and then try the best you can to match up the other side. And I think I'm not going to get the not going to get 100% the first try. And so if you were to, this were your job, you'd want to have a more precise measurement on the placing and then the angles of those, because I did not even try to match up the angles. So that below, that's the air intake. So this thing requires a lot of air, a lot of a lot of compression to keep it consistently flying. So it needs to bring that air in, compress it, and put it into the blades, and that helps with wind gusts and stuff like that. That's about it. And so, that's assembly anyway. So what we want to do is we want to hook up the gear relations, but they have these little visual arrows I want to put up there just to give the readers something to look at in case your parents want to take a look at what you're doing, and give them kind of an idea of what the blades are doing. And it's got these fancy little arrows. It looks neat. Offers no real value, but looks kind of cool. So that one, I'm not sure how it got so out of sync with the rest of it. You have to kind of figure out how we're going to turn that thing. And you do have to look at it straight down from the very top. Otherwise, you're not going to get the angle right. So I'm not getting it right. So best way to get this one is to look straight down from the top view and adjust it like that. There we go. Not sure, 30 degrees. I'm not sure if it's 30, 35. Yeah, that's right. So those are just, you know, if you were to throw this into a magazine or something like that, it'd be great for that. And I think I brought some of those arrows in, the short ones. All right, so we're almost done. Actually, we got to do some gear relations. So what you want to do on the gear relation is, so if you turn one vector, I'm going to call them vector manifolds, then the other one is going to be synchronized with that one as well, because you don't want them turning by themselves. You want them to turn together so that you can actually steer this thing. Otherwise, it's going to be going all over the place. I think if you wanted to turn left or right, you know, you might get it to, each one kind of turns a little bit on its own, but you wouldn't want to go dramatic, because to get it to turn, yeah, you would turn one side a little bit, but you wouldn't want to go into like a spin. You'd want to control that and not turn very fast, but you know, a controlled spin. So yes, you'd want to, in real life, you'd want to make sure that you had the ability to control them either synchronized or independent. So here's the gear relation. So it's kind of hard to see which one is needs to be hooked up. So the blades all have to be turning, and so I think in this situation, 1, 2, 4, and 5 was the blades, and then 3 and 4 is going to be the vector control, the hoods. So I think the first time I messed up, but so that one is 2 and 5 is the front and back. I think that's going to be my first one. And then so now I need to get that one on that side hooked up. And then of course I need to get the hood covers. So I got the front and back hooked up. Now you get the left front, right front hooked up, and then all the blades will be turning synchronized. I need another gear relation. Now I need to find let's say 2 and 5, so then be 2 and it's 2 and 3 is what it should be doing. So if you forget, go back to hover over gear 1 and look and see. I guess I got it right. I got it right the first time. Okay. Alright, so they are working. So yeah, so if you forget which ones are taken, go back, look, edit. So gear 1 is going to be 2 and 5, and gear 2 is going to be 1 and 5. So 3 and 4 is going to be the hoods, the vector hoods that have to be hooked up. So they do turn, but I think what you want to do is, I'm not sure why I undid that. So you want to reverse them so that they don't turn opposite. They want to turn you want them to turn together, but actually that would be opposite. So yeah, you want it opposite direction, because that means that they're turning and making the forward momentum work. So I think I locked it up, and I think what I did is not hold on, I think yeah, I did gear 4. I'm gonna start over. So it's gonna be 3 and 4. I need to redo. Or test out the I'm gonna test out the blades and see. So those are fine. So that'd be forcing it down, so you'd want to make sure you force it up. And those blades would probably not go in the opposite direction. If you want it to go down, then you just slow the rotation down, producing less updraft, and so then that would sink. So you wouldn't actually need to reverse those blades at all. Okay, so let's fix the vector hoods, and let's get it right this time. So it should be Revolute 3 and 4. So just do a visual check to make sure you have it. So it's working. I think that it's the way it's supposed to work. So they are turning the way they're supposed to be turning. So if I were to reverse that, what would that do? So that controls the direction, the upward direction, and the forward momentum. All right, guys, this is the V-22 Osprey vertical takeoff and landing of the USS Carl Vinson, the ship that I was on when I was in the Navy. So this is similar to the chopper that we just assembled. Of course, a little bit different, more of a prototype, but the science is tested. It's not, it's not radical. It's not something that hasn't been tested, but it's the vertical takeoff and then switching to the airplane forward momentum. It's basically a helicopter slash plane, and they're really meant for deploying U.S. Marines and Navy SEALs into places that can't, they need to get to quickly, and there's no runway to land, which would be a swamp or desert or something like that. So, and then they could actually lower straight into a a mountain range or something like that. So they're very versatile aircraft, but they do actually use these in the military, and this is an example. So I'm going to show you this, and you can see how they got them tilted forward to provide the forward momentum and then the upward momentum lift. And of course, you have to make sure that there's clear of any obstructions, and there's no other planes, because you don't want this thing to go sideways, because they're a little bit harder to control than the jets. And there's my lookout tower right up there, right there on the second deck from the top is where I did my weather observations, and that's the radar spinning up there. That's the weather radar. And this is the USS Carl Vinson. I spent 4 years on the ship, and that's the Osprey. So, yep, Navy SEAL and Marine Corps use this aircraft a lot to get in and out quickly, and it's actually pretty silent. The big blades produce a lot of lift for the power ratio that goes into them, so the motors aren't really making too much noise, because you definitely want to make sure that there's stealth involved. So the bigger the blades, the less the motors have to turn and create noise. So you can see it comes straight in. It could land straight vertical, but having the upward momentum and the forward momentum creates stability, and they don't have to change it much to get that forward momentum. And they can change it to go backwards. So the one that we just built, a lot smaller, and it would probably be more geared toward commercial flight. Smaller, but that's definitely meant for combat. The one we just designed is probably going to be something that they would want to use for like air taxis, if Elon Musk were ever to get into that business. Anyway, all right, I hope you enjoyed the video, and see you guys in the next tutorial.